We now talk about the sum of n terms of an arithmetic progression. Sum of n terms. Sum of n terms of an arithmetic progression. The sum of n terms of an arithmetic progression. The sum of n terms of an arithmetic progression is designated. This is usually denoted Sn, and is given by the formula Sn equals n over 2 into 2a plus n minus 1 d. Sn equals n over 2. Just felt like you're writing that into 2a plus n minus 1 d. Or we can write it as Sn equals n over 2 into a plus l, where l is the last term, usually the last term of a sequence. So it's very important to notice formulae. Sn equals n over 2 into 2a plus n minus 1d, or Sn equals n over 2 into a plus l. A is the first term, d is the common difference, and Sn represents the sum of n terms. The sum is usually the addition of a number of terms of usually obtained by adding a number of terms of a sequence together. That's simple. I think we just take just take an example on that. Okay, but before we go to an example, it's important to note this. Let's assume these are terms of an AP. If these are terms of an AP, we'll see that S3, which is the sum of the first three terms, is 1 plus 2 plus 3, which is 6. And at the same time, S4 is 1 plus 2 plus 3 plus 4, which is 3, 6, 10. And we can see that S4 minus S3, the sum of the first four terms, the difference between the sum of the first four terms and the sum of the first three terms is the same as the fourth term, because the sum of the first four terms is 10, and the sum of the first three terms is 6. And when we subtract the sum of the first three terms from the sum of the first four terms, we get the fourth term, which is 4. The fourth term is 4, and that's T4. So we can generalize by saying Sn minus 1 is the same as Tn. So that means S5 minus S4 is going to be T5. S4 minus S3 is going to be T4. S3 minus S2 is going to be T3, and so on. So this formula is very useful. Now we go to an example. Okay, let me take that. The sum of the first n terms of a sequence, the sum of the first n terms of a sequence is given by Sn equals 5n squared over 2 plus 5n over 2. Write down the first four terms. Write down the first four terms of the sequence. Write down the first four terms. Write down the first four terms of the sequence and find an expression and find an expression for its nth term. The sum of the first n terms of a sequence is given by Sn equals 5n squared over 2 plus 5n over 2. Write down the first 4 terms of the sequence and find an expression for its nth term. That means you find the definition for Tn given this information. I think that's cheap. That's a piece of cake. Sn is given by 5n squared over 2 plus 5n over 2. That means we can find Tn easily. If this is Sn, that means Sn minus 1 is going to be 5 into n minus 1 squared over 2 plus 5 into n minus 1 over 2, and that's going to be 5. Okay, yeah, and that's going to be 5 into n minus 1 squared plus 5 into n minus 1 all over 2, which means 5 into n minus 1 is common to the 2. That means 5 into n minus 1 into n minus 1 plus 1. Okay, that's it. 5 into n minus 1 is common to these two terms. And when I take that out, or factor that out of here, I'm going to be left with n minus 1. When I factor it out of here, I'm going to be left with 1 over 2. So I go over that again. 5 times n minus 1 is common to this term and this term. So if I factor that out of 5 into n minus 1 squared, I'm going to be left with n minus 1. And if I factor it out of this one, I'm going to be left with just 1, which is what I've done here. So minus 1 plus 1 is 0. That means 5 into n minus 1 into n over 2, which is simply 5n into n minus 1 over 2. So that's Sn minus 1. Therefore Tn, which is Sn minus 1, is equal to Sn is 5n squared over 2 plus 5n over 2 minus Sn minus 1. Sn is this, and this is Sn minus 1. So that will be minus 5n into n minus 1 over 2. That's how Tn is Sn minus 1. I know Sn minus 1 to be 5n into n minus 1 over 2, and Sn is, I know Sn is 5n squared over 2 plus 5n over 2. So I'm subtracting Sn minus 1 from Sn, and that means 5n squared plus 5n minus 5n into n minus 1. You could there might be this simplification might be done differently. What's important is that the correct definition of Tn is obtained. So this means 5n plus 5n minus 5n squared plus 5n over 2, or 5n squared, yeah, plus 5n minus 5n squared plus 5n over 2. And that means 5n squared minus 5n squared is 0, 5n plus 5n is 10n over 2, and that's 5n. So Tn is therefore 5n. So that's the definition of the nth term. And they said I should find the first 4 terms of a sequence. That means T1 is equal to, therefore T1 is equal to 5 times 1, which is 5. The second term is 5 times 2, which is 10. The third term is 5 times 3, which is 15. And finally, the fourth term is 5 times 4, which is 20. Hence, the first 4 terms hence, the first 4 terms of the sequence, hence the first 4 terms of the sequence are 5, 10, 15, and 20. 5, 10, 15, and 20. And its nth term and its nth term is given by Tn equals 5n. That's it simply. Hence, the first 4 terms of the sequence are 5, 10, 15, and 20. And its nth term is given by Tn equals 5n. Simple. That's quite easy. The expression Tn equals Sn minus 1 is quite easy for finding. It's quite easy to use when you are given this definition of the sum of n terms of a sequence, and you need to find the nth term of that sequence, the definition of the nth term of that sequence. So that's it. Simple.